Okay, welcome to your first AP Chemistry summer video. We will be covering 1.1 today. So it will be the very first section of your packet called moles and molar mass. It should be very much a review, especially if you had honors. If you do not have honors, please just kind of make some notes out in the margin about any questions you have and send me an email if you need to. Just let me kind of do a little disclaimer really quick. So I'll be recording these throughout the summer, and you may feel like I'm a little grumpy in them. Let me see if I can explain that better. You may feel like I'm rushing, and you may also just feel like I'm being kind of curt, and that is not my intention. The reason it may come out that way is because I'm trying to make them short and concise. And to be honest, that's not my gifting. I'm known to talk and be, more chatty, and I don't want to waste your time. So if you feel like I sound kind of mean and grumpy, that's not normally how I teach. I'm just trying to keep it very concise because I know you don't want to spend your summer doing long videos. Okay, so I'm going to share my screen. Yep, that'll work. Okay, so I'm going to share my screen, and you should be able to follow along. You of course, have this in your content library in our notebook. That's where I'm going to be. But you also have the paper copy that you may have filled out. Picked up. You can use either one of them, but here's what I will say. I forgot the other day I started this video. So I'm going to be erasing some of this as I go. I will say that you have to make sure that you fill it out in your handwriting. So if you kind of, look around here, you can see that in Content Library, it's going to auto-populate for you. But you have to either put it on paper in your handwriting, or you have to fill it out in OneNote in your handwriting to get your grade or your daily grade for the summer work. So anyway, let me go ahead and get started. Here we go. All right, so we can use our periodic table to get the mass of elements. And you should remember that we use that mass, the grams of the elements on the periodic table, to convert to moles. We did that several times in honors last year, where we would convert from grams to moles and moles to grams. And when you get the mass of an element off of the periodic table, that is the number of grams that are in 1 mole of that substance. And that is called the molar mass of that substance. Okay. You also can get, though, what's called the formula weight. The formula weight of a substance is basically just adding up all of the atomic weights of all of the elements or atoms in that substance. Now, we don't go into this much in honors or in AP, but originally the way that atomic mass was reported is in something called AMUs, or atomic mass units. We treat AMUs as grams. Like, we would almost say that 1 AMU is equal to 1 gram, okay? To where, like, if you looked at oxygen's mass and you see that it's 15.99, or about 16 grams, that's, you also could say that oxygen's atomic mass is 16 AMUs. So like 16 grams, 16 AMUs, you could kind of treat them as interchangeable. They're not really interchangeable. We treat them that way. But if you were to like dig deep down the rabbit hole of the difference in a gram and an AMU, you would see that they're not identical, okay? But we treat them that way. So if I asked you for the molecular weight of sulfuric acid, which is H2SO4, and I asked you to maybe give that in AMUs, you would just go and copy the grams and treat them like AMUs from the periodic table, keeping in mind that you would have 2 hydrogens, 1 sulfur, and 4 oxygens. So if you look at your periodic table, you would say, okay, I have 2, and the atomic mass of hydrogen is 1.01. And then I would say I also have 1 sulfur, and sulfur is like 32.1 from the periodic table. And then you could also say, and that you have 4 times 16 oxygens, okay? Because we usually round oxygen to 16. It's like 15.999. And when you add that up and do your multiplication, of course, you would get 98.1 AMUs. So that is truly the molecular weight of sulfuric acid. But we generally would report that in grams. Like we would say 98.1 grams. Okay. Now, you need to always do your molar masses from the periodic table, and you also need to keep about 3 decimal places, 2 to 3 decimal places. We talked about that in honors. We do very little rounding. Like I know you see here, I did 32.1 for the sulfur. Technically, I probably should have done like 32.07. You'll kind of see me sometimes do 1 decimal place, but we should get in the habit of doing 2 to 3 decimal places. Now, again, I'm getting these numbers of these grams per element or AMUs per element from the periodic table. Now, I will go ahead and tell you that H2SO4 is an acid. We have that right there to tell you that. We will be doing acids and bases later this year. Acids give away hydrogens. We talked about that towards the end of the year in honors. If you have Miss Ladart, you probably have not really dug into that. But I just kind of want to point out here, do you see the gifting in this wording that it says sulfuric acid and then it gives you the formula, okay? AP is known for giving you the name and the formula instead of you having to like remember all of those formulas or the way that we name acids. So kind of keep your eye on that. It's one of the things that makes AP more doable. So like I said, we will be measuring things in grams, okay? So like it says here, the easiest way to scale up to real world quantities is to use the same number, that number of like AMUs, like 98.1, but instead to report it in grams. The reason in that is that if you really think about what mass is, so we know that mass is what's in the nucleus of an atom. And mass being from the nucleus means protons plus neutrons. That is what lives in the nucleus of an atom. Remember, the electrons live in the outer energy levels, or we sometimes call them shells or rings. But your mass comes from your protons and your neutrons. If you really looked up the mass of a proton and a neutron and did it in AMUs, it would have lots of decimal places. And so we, like I said, do report these masses in grams. We also will be using a very large number called, I should say the mole, a very large number called the mole to help us do some of our calculations. I don't know how much Miss Ladart goes into this. I don't go too deep into it in honors, but basically when we came up with the idea of doing grams using the AMU masses from the periodic table. We wanted to have a standard of a way to like compare all of the elements. And so we came up with the mole. Remember, we use Avogadro's number to determine how many atoms or molecules or anything would be in a mole of one substance or of a substance. So like a mole of donuts is Avogadro's number. A mole of oxygen is Avogadro's number. And remember, Avogadro's number was that 6.02 times 10 to the 23rd. Do you remember that? Okay, so there are 6.02 times 10 to the 23rd, like atoms in a mole or anything in a mole. Okay, so we did use Avogadro's number to do some conversions last year with atoms and molecules. But the standard was carbon. They used carbon, the isotope that has a mass of 12. They used carbon 12. And they said, okay, we're going to say that 1 mole of carbon is 12 grams. And that is how we're able to say that the grams on the periodic table are the amount of grams that are in 1 mole of substance. So when you do grams to mole conversions or mole to gram conversions, you would simply use the molar mass from the periodic table, PT, periodic table, okay? But when you do atoms and moles or molecules and moles, anything other than grams, that is when you use Avogadro's number. Okay. Now, I'll be honest with you, we don't do Avogadro's number much at all in AP, like this 6.02. It's on your formula sheet. We used a little bit, but it doesn't really get as much activity as the whole grams and moles. Now, it says here, a mole of given particles weighs the same number of grams as one of those particles weighs in AMUs. That's just that idea of, we're going to say that grams and AMUs are interchangeable. Now, a molecule of H2SO4 or sulfuric acid would weigh 98.01 AMUs. Okay. And we can also say a mole of H2SO4 weighs 98. Oh, see, I wrote 98.1, 98.01 up here. I may have a math error there. Hold on. Whereas we could also say 1 mole of H2SO4 weighs 98.01 grams. Hold on, did I do a math error up here with 2 times 1.01 plus 32.1 plus... No, it's 98 point. This is truly 98.12. Okay, so that math is checked out. I think this is where I wrote my numbers wrong. Okay, so fix that. Okay, so what do you see here? You see that we could report that a molecule of substance has a molar mass or a mass in atomic mass units, but we generally are going to be simply reporting what the mass of 1 mole of substance would be, and it would be in grams. Now, this is not new to you, okay? Especially if you had me last year. Like, we would do things like this where we would say, like, we would do conversions. Like, maybe we would say, like, 22.13 grams of water, and we were trying to say how many moles of water was that, okay? And we would say, oh, we know that means we want grams of water down here in the denominator, because remember, we're doing dimensional analysis to convert, and we were trying to convert to moles of water. How did we know? That's what the question was about. They were asking us how many moles were in the 22.13 grams. And then to do this conversion, we used molar mass, or the mass that is in 1 mole of substance. That's what's highlighted in yellow over here. So we were like, okay, 1 mole of water would be the mass of 2 hydrogens plus the mass of 1 oxygen, which would be 18.02 grams. And then once you divided 22.13 divided by 18.02, you would solve for moles, okay? So when you look right here and it says, hey, what would 1 molecule of water weigh? Well, that is just simply saying, hey, add up all of the AMUs in the periodic table and report it. So it would be 18.02 AMUs. You're saying 1.01 times 2 for the hydrogens plus 16 for the oxygen. And 1 mole of water would weigh the same number, but now you would report it in grams. Okay. We're not going to be doing probably anything with AMUs this year. Like, I'm showing it to you. It's like the introduction to this unit, but you can kind of forget about it. You're going to be doing what you see over here in green. All of this grams to moles, how many grams are in 1 mole, and you're adding up the masses from the periodic table. Now, we talked about hydrates in my class. We said that a compound that is carrying around water with it is called a hydrate. Okay, it attracts water, and the molar mass must include the mass of the water. Okay, we did this last year when we took that blue powder and we heated it. I'm saying last year. I know if you're a senior, you had me a long time ago, or you may have never had me, but you may have to track with me this year when I say that. We took that blue powder and we heated it. And then we said, okay, when we heat it, the water would evaporate from it and it would turn white. And that is us driving the water off of the hydrated molecule. A hydrate is always written with this raised dot. And so you see the formula for the compound, raised dot, and then this tells you there are 6 water molecules that this iron 3 chloride is carrying around with it. That's where we get the hexahydrate. Now, hopefully some things are jumping out at you. Do you see this 3? Remember that Roman numeral number 3 is used for elements mostly transition elements or metals, transition metals from the middle of the periodic table, when they have more than one charge that they could have. You can't predict it from their from their column or their group on the periodic table. So the reason that I can tell you for certain that I know that the formula for this compound just from these words is FeCl3 is because that 3 is telling me the iron must have been a 3. Iron can be +2. It also can be +6. It's usually +2 or +3 though. So to remind you, some things I asked you to memorize last year. I asked you to memorize that Ag is always +1, that iron can be +2 or +3, and that copper can be +1 or +2. I would still have those memorized, okay? Now, here, they're like, what would the molar mass be of this guy? Well, you would just add up the grams of Fe. There's one Fe, and that is 55.85. And then there's 3 chlorines or chlorides, because remember it's an anion, and that would be 35.45 times 3 of those. Okay, and then you've got 6 waters. And we know that water is 18.02 grams times 6. So you would just add up all of this. 55.85 plus 35.45 times 3 plus 18.02 times 6. And you would get the total. Now, how do we use this? So we will be doing lots of dimensional analysis. I'm about to erase this really quick because I forgot. I had done a recording the other day and there was an error on something. And so I said, let me just re-record it because it was going to be too long. Let me see how far down I need to erase. Okay, so we will be doing tons of dimensional analysis, tons of like multiplication division problems where you have to do that idea of write down what you start with, put diagonal in the denominator across from it, what you want to cancel, put in your numerator what you want to solve for. Okay, this is the meat of chemistry, okay, and AP chemistry. You will be doing grams and mole conversions using the molar mass from the periodic table. Occasionally, you will have to use Avogadro's number. Just know that Avogadro's number is when you are doing things that are not grams, like maybe molecules, atoms, formula units. Now, a formula unit is just like a weird way of referring to an ionic compound. Okay, an ionic compound, let me just refresh your memory, is something that has charges associated with it, ions. Ions are charged particles. And an ionic compound, if you remember, is a metal and a non-metal. Whereas a covalent compound, when you're just sharing electrons, remember that was a non-metal and a non-metal. But when you say like a formula unit, it just means like how many of the compound do you basically have. So here you have an ionic compound of PbI2. And they're saying if you are told you have 3 formula units of that compound, well, that means that you would have 3 Pb's and 6 I's. Okay, because you would like have times 3 of the whole thing. Now, Pb is another metal that has more than one charge available to it. Okay, you're going to see it's lead. You're going to see down here, like they tell you, it's lead to iodide. Okay, so that is where that formula comes from. I didn't ask you to memorize lead. I think Miss Ladart actually mentions it, maybe more than me. Lead is usually +2 or +4, but you would have been able to intuitively figure out that it must have been a +2 just from the fact that you knew that the I was -1, and they gave you the formula. So you kind of had to look at the crisscross of the charges. Now, if you look right here, these are some questions that you can use to practice what I'm talking about. A chemist has 25 grams of lead to iodide. How many formula units are present? Okay. So what they're really asking here, let's see, step 1, how many moles are present? How many formulas are present? Okay. So they're giving you the steps. Some of these questions in this packet are going to say step 1, do this. Step 2, do this. Just know that AP is not going to give you the steps. Okay. This also probably is not a very like realistic type of AP question. You might have to do these things I'm about to do within a question, but it's not going to be probably the actual question. A lot of things in AP take multiple steps, and you're going to have to get used to knowing the steps. But this one tells you kind of what they're asking you to do. So first it says, how many moles are present in these 25 grams? Well, remember, you have to start your dimensional analysis with what you're given. What's your given? What you're given is 25 grams. And you don't really have to keep that 0.0. You do need to think about how that 3 sig figs, 1, 2, 3, and that will determine how many sig figs you'd want in your answer. But just doing your quick rough math, you can just write down 25. So 25 grams of PbI2. We want to know how many moles that is. So I want to convert to moles of PbI2, and I want to get rid of grams of PbI2. This is a grams to moles conversion, so I'm going to need to get the molar mass from the periodic table. I'm going to add up 1 lead and 2 iodides, get their grams from the periodic table, and that is going to turn out to be 0.0542 moles of PbI2. And then it says, okay, well, then how many formula units would be in that? Okay, well, remember I told you up here that there are 6.02 times 10 to the 23rd formula units in 1 mole of substance. Okay, so I can just now say, okay, now I want to go from moles to formula units. Okay, so I can say, all right, 1 mole is 6.02 times 10 to the 23rd formula units. And that cancels out moles and gets me to formula units. And you're going to get 3.27 times 10 to the 22nd formula units. Now it says if the question asks for atoms, they'll be multiplied by the subscript to get the answer. For example, if the question asked for how many atoms of iodine are present, then you would have to multiply that 3.27 times 10 to the 22 by 2. Okay, what they're saying there is that this is telling you that you have this many 3.27 times 10 to the 22nd of the actual formula, but you know that within each of those formula units, you have like a ratio of 1 to 2 of lead and iodine. So you'd have to multiply that by 2 to get actually how many iodines you had. So they're showing you here in one of this whole formula, that's awful, sorry. In one of this whole formula, there are 2 I's because you're looking at the PbI2. So you actually would have double that amount, or 6.54 times 10 to the 22, for your number of iodine atoms. Now, you would have only 3.27 times 10 to the 22 lead atoms because there's a 1-to-1 ratio for the lead with the entire formula. This is the most abstract part of chemistry. I do talk about it in honors. There's like an imaginary 1 there, okay? So if you have 1 mole of this compound, then you have 1 mole of lead and 2 moles of iodide. If you have anything that you know about this entire compound, it would be in a 1-to-1 ratio for the lead versus the whole compound, but a 1-to-2 ratio for the compound compared to the lead, okay? That is better taught by example. Like, I'll try to bring it up next time it happens. Do we have one coming up? I don't think so. Probably not yet. But just remember that not only are these subscripts telling you the number of atoms in the formula, they're also telling you the number of moles that would be in 1 mole of compound. Okay. All right, look at number 2. This is a 0.244 gram sample of calcium carbonate recovered from a sample of hard water. How many oxygen atoms are in the sample? Okay, well, let's look. I have 0.244 grams of CaCO3. Okay. Now, something that is important here is to remember to keep the compound formula with your numbers. A lot of students do not like to do that, but you need to, because you're going to get lost in the shuffle. You can't just have a bunch of floating numbers. Now, you do not have a way of comparing or doing a direct dimensional analysis that involves grams and atoms. If you remember, we had a mole wheel, okay? You had a mole wheel that I showed you in my class, and it basically was trying to show you like how you move around the wheel, okay? You can go directly from grams to moles, and you can go directly from moles to grams, conversions, okay? But if you want to go from grams to atoms or backwards from atoms to grams, you must go through the mole, It is like your in-between step, okay? So I have to convert from grams to moles if I want to do anything with atoms, okay? So how do I go from grams to moles? I've got to do molar mass. So the molar mass of 1 calcium, 1 carbon, and 3 oxygens is 100.09 grams. And that is always the number of grams in 1 mole of substance. When you add up the number of grams or the molar mass of a substance from the periodic table, that is the number of grams that are in 1 mole of substance. This is the definition of molar mass. Now, this is where I was talking a minute ago about using your subscripts as moles. Watch. When I have 1 mole of CaCO3, there are 3 moles of oxygen in that 1 mole. Okay. What did I just do? I used my subscript. I'm saying that when you have 1 whole mole of compound, you would have 1 mole of calcium, 1 mole of carbon, and 3 moles of oxygens. I'm using those little subscripts as moles, the number of moles. Okay. If you did not know that, or if you're like mind blown by that, highlight, circle, star, underline. And then now I've got rid of grams. And now I'm going to get rid of moles of compound. Now I'm left with moles of oxygen. What do I care about? The question, sometimes you have to look back and say, what am I even doing? I'm getting so lost. The question was all about oxygen atoms. So I'm going to say, okay, well, I need to get rid of moles of oxygen. And I need to solve for atoms of oxygen. How do I know I need atoms of oxygen in my numerator? Because that's what the question's about. Well, how do I know how many atoms are in a mole? 6.02 times 10 to the 23rd. And you should get 1.47 times 10 to the 23rd. Nope, actually, I don't think that's. Oh, I need to put that on my calculator. Okay, I don't have my scientific calculator in front of me. I think I copied that from something else. When the video is over, because I'm almost done, I'll come back in and add the answer here. I just don't have my calculator in front of me. I don't want to try to do my phone scientific calculator. Okay, so I'll put the answer there in just a second. It's going to be there. So this is already going to be filled out when you started the video anyway, because remember, you're filling it out with your own handwriting. But I'm not going to go back and erase it. Well, maybe I should go back and erase it. I'll leave that answer up there if I choose to go back and erase it. This is the first year I'm doing it this way, the first summer. So there's going to be some times you hear me talk to myself. So just bear with me. Okay, so now what do you do? To finish out 1.1, okay, and I will say this video probably is a little bit longer than what I wanted it to be, but it's my first one and I'm at the stage for a couple of things. When it says additional practice, okay, and you see all this right here, if you look, there's an answer key after that, okay? So what I want you to do is I want you to do these. It would be better if you do them now because you just watched the video. Check your answers, okay? And I do want to see some notes here. Even if you just write a smiley face or you just write no, like I don't need any additional help. But I want you to put some notes here if you're like, I did not know how to do A, B, and C, or I'm still confused about such and such. Okay. But remember, you can email me throughout the summer and ask me questions. And that's probably the best thing to do, is to not let this kind of fall behind on you. Now, let me show you some things I just added to. Some of this isn't correct, like it's from last year, but some of it is correct. So I just covered 1.1 and 1.2. So if you click on Unit 1 in the content library, you can see there are some slides that are go along with what we just did. Okay, so 1.2 is what I'll cover next video. You also can see the AP Chemistry formula sheet. Okay, it's right here. You're going to want to be very comfortable with that by the end of the year. Okay, but I do think we do a good job with that. The kids say, gosh, at the beginning of the year, this looks awful, but it's exciting because at the end of the year, we recognize everything on it. And then there is this thing too that says understanding the formula sheet. Okay, and there's like just some people that are trying to, like, I didn't make that slide, these slides, but they're trying to help you understand what things are. There's also the AP Chemistry periodic table. I want you to notice that there's no names of elements. They do not give you the names of elements. That's not usually a big hiccup, though, because the ones that you need to know we usually use so much that they become pretty easy for you. Okay, so I'm going to stop right here, and then the next video will be 1.2. You're welcome to go ahead and do that, kind of back to back, or you could leave, some time in between. Be sure to let me know if you have any questions.